Hi, my name is Nico, and I'm a second-year graduate student at Cornell University at the Animal Science Department. And my research is trying to find management practices for management and nutrition for milking sheep in short and frequent lactations. And just to tell you a little bit more about the background to this research, the sheep dairy industry in the US is a very seasonal business. Traditional dairy sheep are utilized, and dairy sheep tend to be seasonal breeders, meaning that they breed once a year in fall and they have one annual 180-day lactation. At Cornell University, for the past 1.5 years, since October 2016, we've been milking meat ewes. We've been milking Finn sheep and Dorset crossbreed ewes, and the advantage in comparison to dairy sheep is that they are aseasonally polyestrous, meaning that they are able to breed and lamb and lactate year-round. So what we're interested in is, this is a very intense management system. We're milking them on the SARE accelerated management system, which is adapted from the meat sector of sheep production. Again, it's a very intense system, so we're looking at what kind of diets do we have to feed those ewes to allow them to thrive in that intense system. So how can we have them to be highly productive in terms of milk production, but also maintain their body condition, optimal health? How can they be prolific, and how can we maintain high conception rates? So we have them on a dietary trial, and we're feeding them 3 different diets, and that's basically the core of my research, where the research is structured as a Latin square design, and we're looking at 3 groups of sheep that are milked consecutively 3 times. Each of these 3 groups are milked 3 times in 2 years. So each group has 3 lactations, and they're being fed 3 different experimental diets. And these diets differ in their fiber level and their potentially fermentable fiber. And now I would like to show you a little bit of the results that we have so far. So this project is not over. We're going to be milking these ewes until September 2018. So we still have about half a year more to go. But so far it's been very clear that one of these diets containing around 30% PFNDF, potentially fermentable fiber, has fared the best. These groups of ewes have achieved milk yields up to 2 kilograms per day, which is around 4.4 pounds, which is actually a pretty good result for them being meat sheep. And we've also found that their lactation curve obviously differs from lactation curves of traditional dairy sheep. Their persistency is not as high, meaning that they milk only between 73 and 103 days. However, their milk yields have been very high, so that is considered to be a success. And we've also observed that as their milk yields dropped, their feed intake also declined. That makes sense, right? Milk yields go down, feed intake goes down as well. And because I earlier said that we are trying to figure out ways how to keep them stable in their body condition, looking here at this graph, we can see that their weights, they gained weight as soon as the milk production dropped, right? So this basically results in our system to work. We have high milk yields, we have adequate feed intakes, and we have a maintenance of health and body condition scores. So in terms of milk yields, we can definitely conclude so far that it is possible to milk ewes in such an intense system without having detrimental impacts on their health or their body condition. Something else that I would really like to point out is our breeding success. We were able to breed these ewes completely out of season, and we have conception rates ranging between 76 and 100%. So we used a broad variety of breeding strategies, including cedar and sponges, so hormonal treatment, but we also had completely natural breeding. And within that broad scope of breeding strategies, again, we had between 76 and 100% success. And what I would really like to point out is that most of the ewes were able to breed and then lamb within the first cycle. So one sheep reproductive cycle is 17 days, and most of them, ranging between 75 and 93%, conceived in that first cycle and then lambed in that first cycle. And that has a huge amount, huge impact on labor. Because what it means is that a lambing season can be reduced from 1 month or 2 reproductive cycles to 1 reproductive cycle. And when we're thinking about having 5 lactation periods per year, according to the STAR cycle, that just means that we can reduce labor, we can reduce cost, and we basically raise sustainability. And yeah, we also have a very high success rate in terms of our lambs' survival. We had 3.2 lambs born per ewe per year, and we only have a 2% death loss. So concerns that ewes might not thrive as well under such an intense system did not hold up. Like, we have not experienced any detrimental effects on health and thrive and vigor of lambs or ewes. And I'd just like to briefly conclude that so far we have had a great success with this experiment. It is possible to milk and manage ewes for dairy purposes under the STAR accelerated lambing system. And what we actually found is that with that system we can offer a gateway towards a dual purpose breed. So we can not only have meat production or milk production, we can have both. We can have a lot of lambs and we can also have milk. And hopefully in the future we can gear this research a little bit more towards pasture utilization. That is my personal interest. I would like to research a system like that more on pasture-based systems. And hopefully we will gain a little bit more interest from farmers around the Northeast that are interested in maybe trying to milk their sheep year-round.